Okay, so this is going to be the first video of two for Algebra 2, Unit 3, Day 8. And in this video, I'm going to real briefly, go over just a few talking points about polynomials in general. So let's kind of lay it out with these EQs. So EQ1, what is a polynomial? And you see I iterate in standard form, right? So a polynomial in standard form, so let's say we have P of X for polynomial that's a function of X. Standard form, we already know what that looks like. It would be a times x to the nth power plus b times x to the n minus 1 plus c times x to the n minus 2, and so on. Okay, so basically, so for example, we could say, I don't know, 2x to the fifth power plus 3x to the third power plus, and I guess I shouldn't say n minus, we'll just do that. So 4 plus 4x to the third power, and so on and so on until we get to the lowest power of x that we have, right? So we've already talked about writing quadratics in standard form where we have ax squared plus bx plus c, right? So we have 2, 1, and 0 here, right? So this is just, it's not really anything new. Standard form is just where we're writing in descending order from the highest degree term to the lowest degree term. Okay, so what is the degree of a polynomial then? So the degree of a polynomial is the highest degree in that polynomial. So for example, right here, we have 7x to the fifth plus 2x squared minus 3. This would be a fifth degree polynomial. Okay, so another example, let's say we had f of x is equal to 5x to the third power plus 10x squared plus 3x minus 7. All right, so again, this is standard form, right? Just like what we have here, 3, 2, 1, and x to the 0 technically, right? Now, what this tells us, right, this is why it's important. What this tells us is because this is a third degree polynomial, right, that means it's going to have three roots, right? And roots is going to be synonymous with x-intercepts, well, we'll say ints, and it's also going to be synonymous with uh, what we would call solutions, okay? So anytime you hear me throw those words around, intercepts, roots, solutions, right, the degree of the polynomial tells you how many there's going to be, right? So quadratics, for example, are second degree polynomials, and they always have two roots slash solutions slash intercepts, okay? So this one right here, because it's third degree, it has three of them, right? This example that I first showed you here, because it's fifth degree, it would have five intercepts or roots or solutions, right, respectively. So let's talk about how that affects geometry, right? So, and well, maybe this will work out if I pull up a graph on Desmos. I don't know. I'm not going to try to just draw it by hand because that's probably going to ruin everything. So let me pull this up real quick. And hopefully, if this works out right, because I just made up this function, if this works out right, this is going to really motivate the point that I'm trying to get across. Okay, so I don't think I want the screen that big. Let's see here. Once again, this is me just improvising as we go. So 5x to the third, 5x to the third plus 10x squared plus 3x minus 7. Okay, so yes, what I wanted to happen indeed did happen. Okay, so this is our function, right? And it's pretty horrible looking, right? But the thing I want us to notice, right, is that it's a third degree polynomial, right? And it has 2 points of inflection, right? So it's increasing from negative infinity until we get to right here, this point of inflection about negative 1.161. It's increasing until we get there. Then it starts decreasing. That's why we call it a point of inflection. Then we have another point of inflection where it goes from decreasing back to increasing, right? So the point is, it's third degree, 2 points of inflection. So now if I mess with this a little bit, 10x raised to the fourth minus 5x. Let's see if this does what I want it to. No, it does not. It 100% does not do what I want it to. But anyway, okay, so because that's a fourth degree technically, that fourth degree that I threw on there, right? And it didn't do what I wanted, but that doesn't matter. You still got to see this. Um, it would have 3 points of inflection. Okay, so because this is third degree, we know we're going to have n minus 1 points of inflection. Okay, and again, those points of inflection are just basically where we change from increasing to decreasing. Okay, and I mean, you saw on here it was increasing, then it did this, right? We have 2 points of inflection in minus 1, right? Points of inflection. Okay, so uh, last thing I'll end off with here, and you can just go ahead and pause this screen and write down anything from here that you want to do, but I'm not going to talk about all of this. Most of this is stuff that we already know. For example, you know, if it's a 0 degree polynomial, well, then that just means it's a constant, kind of like this minus 3 here is times x to the 0. If it's linear, right, that means, you know, we have y equals mx plus b. So this is to the first power, right? If it's to the second degree, and we already talked about this, if it's a second degree polynomial, well, we know it's quadratic, duh, okay? Third degree is cubic, fourth degree is quartic, fifth degree would be quintic, and so on and so on and so on. Not that big a deal to know that stuff. All this stuff down here coming through, we know all of this as well. We've studied it already previously. Trying to think if there's anything I'm missing. No. Okay, so if you have any questions about anything about polynomials, you know where to find me. Otherwise, shoot me an email. Goodbye.